Hello everyone, a very warm welcome from Edu Supplement. I hope you all are doing very well and having a very good health. Yes, there has been a gap since we posted our last video. Due to some unavoidable circumstances, I, along with the team of Edu Supplement, need to take a break. So we will start from today, and I promise you to continue our videos regularly from now on. So today, what I'm going to do is that I will start our new journey or a journey after break with respond to some requests. So I am having some requests to all of you, which I'm very much thankful that you are watching my videos and sending me requests. So today my plan is to restart with responding to some of your requests, and I have planned that with my regular videos I will post some videos based on your request from now on. So from time to time you will have some of my regular videos and some of videos that I have been requested for. So today our video will not be related directly to SCAPS. Rather, today we will deal with how to deal with the data that we have obtained from any kind of softwares. So today our target is to work with the data that we have obtained from SCAPS and how to visualize it. And to visualize it, we can use any kind of software or any type of software. But today I will show it a very popular software in engineering fraternity, that is MATLAB. So our video today will be of how to plot or how to visualize the data that we have obtained from SCAPS in MATLAB software. So let's start. First, I will give some background of what type of data we will be reading in MATLAB and visualizing it. So today, as my video is targeting mainly on the solar cell based research, so today I will take solar cell data and I will take data from SCAPS, of course. So here is my SCAPS window, and of course you might have remembered if you have watched my previous video. So I have been working with this video with this structure in a couple of videos, so you should have remembered it. So this is the structure that I'm working, and today my target is to visualize the variation of performance with the change of thickness. That is, I want to plot the thickness influence on the performance parameters. So to do that, I have performed batch calculation. So I have made a separate video for batch calculation, what you can find in my channel. So you can watch it, how to do batch calculation and what to remember to do batch calculation. So here, just I want to give a very quick review is that in batch calculation, my target is to change the thickness of perovskite layer. So I have changed the thickness from 300 nanometer to 1200 nanometer at in 10 steps. So I'll be having 10 data, like I'll be having results from 300 nanometer thickness, then 400, then 500, and so forth. So after performing this batch calculation, I have got this 10 IV curves, and for each IV curve, I'll be having the performance parameters, that is open circuit voltage, short circuit current, fill factor, and efficiency. So these are the data. Now, first, I have to collect this data and transfer it to any Notepad or Excel file or Microsoft Word, anywhere you prefer. So today I'll be using Excel. So I have collected all this data from Excel. You might be wondering, if you are having many data in SCAPS, is there any easier way to read this data to Excel? I will say yes, there are some ways. And for that, you must have a little bit of Python knowledge. And hopefully in some other video, I will show you how very efficiently you can collect all these data using some Python skills. So you have to wait for that. All right. So here, after collecting the data, you can observe that the first column is for thickness, the second column is open circuit voltage, the third column is the respective short circuit current, the fourth column is fill factor, and the fifth column is efficiency. So now what I'll be doing is that I will read this data to MATLAB and then visualize it. That is in a very plain way to put. I will just make a plot of it. You might be wondering if I'm taking this data in Excel, can't I be able to do the plot in Excel as well? But yes, I could have done that. But Excel to me is not a very good platform for data visualization, especially when we are concerned with these plots for high-end research paper. Because in research paper, they have different kinds of requirement, and to fulfill those requirements, you must have such kind of platform that provides you much flexibility, much tunability, and for that purpose, to me, Excel is not a very good option for data visualization. So you must read this data into some other software. And today, that I will be doing with MATLAB. So let's start without further discussion. Okay, so this is the MATLAB interface, and I hope if you are from engineering background, you might have faced this window at any part of your undergrad or grad courses. So now let's start. So this is a file, M file, that is the script file in MATLAB. So first, what we have to do, we have to do some initialization. So I'm not talking about all these details. So the first initialization is clear all, then close all, then CLC. They have their own uses. Then if you need help, just put a comment on, comment on these types. I will give you the answers. So now our main target is to read that data. To read that data, we need to use a built-in function of MATLAB, and that built-in function is XLS read. As I'm reading an Excel file, if I'm not if I were to read some doc file or text file, then I have to use some other functions. So today I'm using Excel. So for to read Excel file, I have to use a function, and that function name is called XLS read. So this is important to remember. So of course, in a function, there must have been some argument. So there is an argument, and the argument will be the file name. And to put the file name, you have to provide the name under single quotation. So please remember, when you are putting a name or any statement in MATLAB, you have to put inside single quotation. So I have to put the name of my file. So let's go to the name of my file. So this is my file, and the name of the file is solar cell data.xlsx. So the extension is also very important. So here our name of the file is solar cell data. Sometimes when you are writing the name, it's better to copy the name. So for that, let's go to my file. So suppose here is my file. So let's just copy the name of the file, because if you just miss any uppercase or lowercase, then the file will not be found, and MATLAB will not be able to read. So here is this, and then we have to put the extension XLSX. So this is the way you can read this data. So let's first check it if the data has been read. But before that, there is a very important thing I would like to remind you. If you want this data to be read by MATLAB, then one thing you should ensure is that the MATLAB script file and the data file must be saved in the same folder. So if you take a look in this folder, the folder is MATLAB video 1, and the data and my script file. So this .m file is the MATLAB script file, and these two files have to be saved in the same location. Now you might be questioning, you might ask me question that is this the only way? No, you can do that. That is, you can put Excel file in different location of your computer and put the script file in another location. But for that, you have to provide the location of your Excel file in the MATLAB. That is, here I have not provided any drive location, but if you put your script file and Excel file in different places of your computer, then before the file name, you have to provide the driver link. So the driver link should be this. So today I'm not doing it because my script file and my Excel file are in the same location. But if you are not doing it, then you have to copy this driver location and then you have to paste it before before your file name to read it. So okay, fine. So as I have satisfied the condition, so I don't need to put the driver location here. So now let's see if the data has been read properly. So let's run it and see if the data has been read. So let's place that to path. Okay, it is running. All right, let's see. Yes, this is my data, isn't it? Okay, may not the way I want, but yes, it is. The data has been read. So here is the data, and if you want to check it, if the data is proper, then you will find there is a couple of similarities. There are 5 columns, so the data has been read into 5 columns. So now what we have to do is that we have to store this data into some labels. So we have to store the data. So let's put this data into a label. Suppose I'm saying the data is stored in a label named data. That is, I'm storing it in some location, in a specific location. So now what next? The next thing is let's make this data more readable to me so that I can understand my data is looks like this Excel file. To do that, we have to format a little bit. So let's do some formatting, and that format is short G. So short G is a format style where MATLAB takes the data and format it in such a compact form that there will be total 5 digits in the data. So if you are having longer data, you will not use it. You need to use different formatting, and in some other video I will discuss about it. Or if you have any particular requirement, just put a comment in or put a question or request in the comment section. All right, so let's see what happens after I have done this formatting. All right, so it's not showing anything because I have not asked to show something in MATLAB, so I have to ask it to show me the data. Now look, yes, in the data location or in the data label, there is a matrix, and the matrix is showing the data the way I want, the way it is showing in Excel. So now let's go and first take a target what I want to plot. So before that, just please make a comparison with the data from the Excel file. As you can see in the Excel, in that first row there are some labels, that is which of the data represent which. But in MATLAB, what you will see that it starts reading the data after the labels. So what kind of label you are putting here, these labels will not be read. MATLAB will be reading only the data. So you have to remember which data means which part of your Excel. So here the first column is the thickness, the second column is the open circuit voltage, the third column is the short circuit current, the fourth column is fill factor, and the fifth column is efficiency. So now let's take a target. Suppose we will be plotting today thickness versus efficiency first. So first let's separate the thickness. So I want to put the data of thickness. I want to take the data of thickness from data matrix and put it into another label or another place which is called thickness. So to do that, I have to extract the first column and put it in thickness. So to extract a column of a matrix in MATLAB, what you need to do, you have to write down the name of the matrix. So the matrix is data, and to have a column, you have to put a colon first, then comma, and then the number of the column you want to select. So here our column is first because thickness is our first column. So if I want to separate this, I have to write this. So this represents first column of data matrix. Similar way, if you have to separate any row, then you have to put the row number first, then comma, then colon. So this is the format of extracting any row or column in matrix. So here our purpose is done. That is, the thickness has been separated and is put in a variable, that is thickness. Now let's go to, we want to take the efficiency, and efficiency is in the fifth column. So let's put another variable or label. So I have taken another variable, and now I want to extract the thickness from the fifth column of data. So data will be the fifth column of the data matrix need to be extracted to efficiency. So now if I run it, what I will see that there will be two tables. One is thickness, another one is efficiency. Nothing will be shown here. So if you want to see it, if the thickness has been taken properly, so this is the thickness as you can see, and in efficiency these are the efficiencies of that solar cell. Now we want to visualize it. To do that, you have to use another function of MATLAB which is called plot. So in the plot, first you have to put the variable along x-axis, which should be thickness, and in next the variable of y-axis. This is a two-dimensional, so there should not be any more variables. So this is that much simple. Now just run it and you will have your proper visualization. That is, you will get the variation of efficiency with respect to absorber thickness. So let's run it. Okay, it is running. All right, yes, this is your variation of thickness in x-axis, and in y-axis you will be getting efficiency. So this is the way you can plot. Now there is something you can control here that I have already told you. You can put your required things here. Suppose you want to give an x label to understand it properly, then what you need to do is just put x label and then write down what you want to write there. Suppose this is absorber thickness. Absorber thickness, and the thickness is in nanometer. Now we want to put some y label, so let's put some y label. So if we want to put some y label, suppose the efficiency, no, the spelling is wrong. All right, efficiency. Efficiency. All right, it's fine, right? Okay, so let's run it again. Yes, so this is the plot of efficiency versus thickness. Now suppose you want to plot the open circuit voltage. What you have to do is that you have to declare another figure. So suppose the efficiency I want to plot in figure 1. So let's give a tag here, then it will be my figure 1, and I want to plot open circuit voltage in figure 2. So figure 2, I want to plot the open circuit voltage. So what I have to do, I have to take the thickness. So our thickness has already been taken. So let's take the open circuit voltage. So open circuit voltage, and you need to remember where is your open circuit voltage. Your open circuit voltage is the second column. So you have to extract the second column for this purpose. So my matrix is data, and in the data matrix I have to extract the second column in open circuit voltage. Then I have to plot it. That is thickness, then VOC. And of course, let's put some label. Some labels are same, so just we may copy it and paste it here. So this is absorber thickness, and this is open circuit voltage. Open circuit voltage, and this is in volt. So let's run it. So let's see what happens. Okay, so as I have run it, you can see there are two plots. So the figure 1 is for the efficiency, and the second figure is for open circuit voltage. So the second figure gives you the variation of open circuit voltage with absorber thickness. In similar way, you can do it for short circuit current and fill factor. Why not do it? So let's just have a copy of this part. Why not from here? And just paste it here. So suppose I wanna plot short circuit current in figure 3. So let's give a different variable name or variable label, whatever you want to say. So my short circuit current is in 3, column 3, and this will be short circuit current, so absorber thickness. And today I'm making a mistake. My absorber spelling is wrong in every places, so let's correct it. So now here we are having short circuit current density, and whose unit in the SCAPS was milliampere per centimeter square per centimeter. Now here is a thing that you need to remember. When you are putting a superscript in any place, in any statement in MATLAB, you have to do it like this. You have to put this sign from keyboard and then put the superscript. If your superscript contains multiple letters or multiple characters, then you have to put this second bracket to keep all superscript. Otherwise, MATLAB will consider only one character. So here I have only one character, so I might have omitted this second bracket or curly brackets, but I'm not doing it today. So here I'm putting it. So now So this is my short circuit in figure 3, and now let's do it for fill factor. Suppose in fourth graph I want to plot the fill factor. So in the fourth graph I want to plot the fill factor. So we have to put another variable name or variable label, and it is in the fourth column if you can remember it. So fill factor. So this is our fill factor. So let's run it. So we will have now 4 variations. Okay, yes. So here is fill factor, here is short circuit current, then here is open circuit voltage, and here is efficiency. So these are the 4 plots you are having from your data. So this is the way how you can work with different kind of data, and then you can read these data in MATLAB and you can visualize it the way you want. So this is very simple. I think you will like it when you will be able to use it rather using different kind of tools for it. So thank you very much. See you in the next video.